Waters is a solution provider for sample preparation, chromatography, mass spectrometry, and informatics solutions. And what I'd like to talk today about is a little bit about mass spectrometry and touch on this qual-quant discussion. Whenever I talk to groups trying to get more information, and that's what this is all about from their current workflows, they face me with three things. Can I get more sensitivity? Can you make it easier? And if I'm doing quantitation, can I get some qualitative information? If I'm doing qualitative profiling, can I get more quantitative information? And one day maybe we'll get to the point where the tandem folks and the high-res folks will have one instrument to do both applications on, but there's still a little bit of middle ground between the two. And I want to talk about the two instruments that we introduced this year at ASMS, the Xevo TQS and the Xevo G2 QTOF, and some of their capabilities and their ability to do both quantitative and qualitative work. The first thing is the Xevo family of instruments builds upon the IntelliStart fluidics that we've been working on over 5 years now, and it has automated calibration routines, and in the case of the MRM tandem quad situation, it can develop the MRM methods, put them in a library, and pull them down for you. And then also during the runs, make sure that the instrument's up to optimal working conditions by checking the solvent blanks, standards, and QCs, and can notify you during the run. So the first instrument I want to talk about is the Xevo TQS. And at the heart of the TQS, it's a step change in sensitivity and performance. And what gives us that is this dual conjoined traveling wave ion guide device, which lets us open up the sampling orifice a little more to let more ions into the instrument. But by pumping the ions up into a second conjoined traveling wave ion guide, we could get an off-axis separation of the neutrals and poorly desolvated particles going through and pump them out in the vacuum system and sample all the ions that we generate and sample them into the mass spectrometer. So what does that give us? Well, we would expect on a tandem quadrupole excellent linearity and good sensitivity. In this case, over our previous Xevo TQ instrument, we get about 5-fold increase for this compound. But as being a former demo chemist, I realized, well, it's going to be compound dependent. So what we see on average is an overall 40-fold increase in sensitivity and an order of magnitude increase in signal to noise, which is the real measure of sensitivity on an instrument like this. In some work we did with Ian Wilson at AstraZeneca, we can also show that using the scan wave collision cell technology, we can also get full scan information on this instrument without sacrificing quantitative performance. And we can get information about metabolites, about background matrix, and use that information when needed to get a qualitative profile in addition to doing our quantitative work. So the key point is we can operate in the MS-MS and the MS mode without sacrificing quantitative capability. Now on the high resolution side, we've talked a lot about what can be gained for high resolution profiling in the proteomic and the metabolite world. And what I'd want to point out is we can do that. We can get excellent resolution, mass measurement accuracy, and spectral acquisition rate. But we can also do that for all the product ions in our unique proprietary MS to the E mode, where we sample all our product ions and all our precursor ions. We've been doing that on our TOF products for quite a while now. Now, what's new in the Xevo G2 QTOF? We've taken advantage of the Synapse G2 QuantTOF technology and put this on our benchtop instrument to get 5 orders of linear quantitative dynamic range on our TOF detector in MS and MS-MS mode. And you're not meant to read this chart, but essentially, this is a Target Links Quan report. Our high-res profiling data is fully compatible with our quantitative workflow. And what I want to point out is this looks exactly like our report that would come off our tandem quadrupole instrument. So we can do the profiling work, and with the appropriate standards in the analytical run, we could do true internal, accurate, absolute quantitation. Now, of course, if you don't have a standard for say in the proteomics world where you may have hundreds of peptides, you can use relative response factors to do internal relative quantitation as well. So what I just wanted to submit to you is that, yes, while perhaps the ultimate solution might be that one high-res accurate mass information, there's still a whole group of people out there doing targeted, specific, low-level quantitation who could benefit from additional work, additional qualitative information. And of course, we're striving to provide you with additional quantitative information for your profiling work. So thank you very much. We're downstairs in ballroom 1, I think.